shadows, the black things,
I think we just
or
let
shadows
it-
of the blocks of rock
Settle
that
out.
are
Settle
exposed
out.
on the
Okay.
seafloor.
Me too.
So once it's possible to zoom in, we can take a look at this patch of dark stuff in the upper part of the field of view,
Right, come on in, video.
because that might be
Where we're going
biologic.
I know.
Not sure. It certainly has
Do you have any more?
Oh, I see. Yeah.
something growing off of it, but I think the black stuff itself is rock.
That's shadow.
But there's dangly somethings.
Yeah, the dangly somethings or the sticky up somethings. Don't know whether it's dangling or sticking up.
I gotta push ahead.
It
Sorry.
looks like,
No worries.
to me, it's really reminiscent of the bearded rocks that we saw at 10,800 meters down
Judging
in
by
the Serena Deep.
Stereos' sonar, I think you
So
boys should pull up a little bit.
the prop wash
Yeah.
just cleared off some of the light sediment from the surface of the material that's exposed on the seafloor.
Diva, what do you think those black things might have been?
Really
I'm looking back
thin,
as far as I can.
thin little filaments.
Coming up,
I'm guessing bacterial, but
Yeah, maybe.
I don't know.
I mean, not rock for sure.
No way.
Yep, keep coming, keep going.
I'm coming.
Let's go fast.
$30 meters a minute.
So this is Deb,
Hi, Deb.
and I have to say this is totally awesome. Like,
Absolutely.
just fantastic.
All right, tilt forward a little bit.
Deb, were you on the Lost City
No,
expedition?
vertical.
I was on the 2003 Lost City expedition, which actually used Atlantis and Alvin
Slowing down a
and
little.
Abe. So we used a submersible
Yeah,
and a autonomous vehicle to map the area and do dives there. So I actually got to dive in the Lost City hydrothermal field. And then I was a participant in the telepresence expedition. I was a shore-based scientist for the 2005 Lost City cruise.
And we're coming up now on another patch of really pale-looking outcrop.
Can you tell us a little bit about Lost City, Deb?
Wait a minute.
Wait a minute,
Just
stand
a
by.
sec, Deb. Right below the pale outcrop, you can see vertical white lines in the rock, and I suspect that's
This is
serpentine. Veins of serpentine in peridotite.
All right.
I completely agree, Patty. That's exactly what
Your
it looks
sonar
like
is
to me as
clear.
well.
That's the top of it.
I'm just blown away,
Or
Deb. This
it
is
slopes
just,
way off.
oh, man.
So
Yeah.
you'll recall
Right.
Deb and Diva
You
were
wanna,
our science leads
still
on leg
moving
one.
forward?
Diva was
I
the
think so,
biology
but-
science
Okay.
lead, and Diva was the biology science lead, and Deb was
So
the geology
let's come
science
down a little
lead.
bit. We'll take some shots.
Yeah, I'm hoping
And just keep an eye on
You
your
want me to
sonar.
come back?
if we can find
Keep an eye on your
if
sonar.
oh boy, that'd be great. If we can find some chimneys that are associated with any of this, boy, Deb, we would love to hear from you about similarity comparison to Lost City. But let's just take a few minutes as we get close to this to talk about what we're seeing here. This is far out, folks.
So watch, we had
I
to
mean, this is
cover
totally weird.
some
Patty, have you
elevation
seen
there
stuff
because
that
of the
looks like
cliff
this
face.
before?
I have never seen stuff that looks like this. I'm sorry. Go ahead, pilot.
So just to give you an update, we had a significant swing left in our move, even though we moved the ship backwards. So we had to shoot up vertically to avoid hitting this cliff. Hence why we weren't able to stay down at the bottom.
I understand. Yeah, I figured that was what was the problem. So, no problem.
God, this is so
Should I
cool.
turn to face you?
If we
Yeah,
as
you can turn a little
we
bit.
I don't,
take a closer look, if we see any animals, then video be great to try to
That's fine.
get a close
I'm
look
way
at them.
out.
So this is
Yeah,
serpentinite with
I'm gonna
carbonate
back up.
cracks and
I can come down a
carbonate
little
cap.
bit and give you a little
I
more.
wonder if it's a carbonate crap. Oops, said a wrong word. I meant crack. Sorry,
So
folks.
it's combined
I just
cap and
Yep.
crack.
Oh, how embarrassing.
Wow, the view in Sirius is stunning.
That's okay, Patty.
Oh, thank you, Deb.
That can be a new
Sorry, do you want
new
to zoom
term.
in serious
No, we
just
won't
a little
use
bit?
that term. But it does
You know, I
look
think
like a
it's almost
carbonate
more
cap
impressive
on the
just
top
showing
of
the
this.
scale of the thing.
Okay.
And I have never seen,
I mean,
oh my goodness, I've never seen such
Ooh, what's
an
that?
expanse.
Yeah, what's that?
If that stuff is all carbonate, it's like a mantle. This is the biggest carbonate field I think anybody's ever seen on the seafloor. This is tremendous.
I mean, this is starting to look a lot like Lost City to me.
Oh,
wow.
Lord. Oh, my goodness. Oh, Deb, I'm getting goosebumps here. I mean, absolutely. It's cold in this room, but these goosebumps are from excitement.
I'm going to try to text Deb Kelly from the University of
Yeah,
Washington.
absolutely.
The original
Oh, yeah.
found Austin. See if she can.
Oh, man.
If there's any way I can get her on time.
Okay,
Pilot?
thanks, Deb.
Yes, go ahead.
Wow. So I'm behind you.
Pilot,
So
is
I'm
it
just now-
possible for us to kind of hang around here a little bit?
Absolutely, anything you want.
Oh, thank you so much. Wow.
Yeah,
Oh,
I know. And take a look at the shot from Sirius, too, just looking down on that.
woo, can't believe it. Oh, wow. Folks at home, I'm in seventh heaven. we see these, they're fairly large chimneys on the tops of the seamounts, but what this suggests here is that there is diffuse flow through maybe thousands of cracks in the mantle rock right beneath this area, and fluid is seeping up from the downgoing plate, interacting with seawater on right as the fluids come out and creating carbonate encrustation over the entire surface of the seafloor. And the only thing I can think of that would produce so much fracturing right here is the fact that just outboard of the trench and a giant seamount is being subducted here and is uplifting the overriding plate's ledge. And the person who mapped this seamount is a guy named Chris Smoot, who worked for the Navy and was in Base St. Louis, Mississippi. He was working, he's retired now, and I think he's living in Hawaii. I doubt that he's aware even of this, but if you are, Chris, that seamount that you named Friar Gio, I'm going to bless for the rest of my life, because it may be uplifting the seafloor as it is being subducted. And so what could be happening is it's breaking up the seafloor as it uplifts it, lots and lots of fractures, and producing avenues for fluids to escape from depth and come up to the seafloor.
Yeah, you're still moving a little bit.
I'm still moving.
Go ahead, Rich.
So.
Barely.
Yeah, I wonder. I'm thinking about the setting here, which seems to be, maybe diffuse venting and through cracks and through those little holes and fissures we see.
Thank you, Rich.
And I wonder if that's why we're not observing any biology. Is that there's just such a diffusion of the chemicals and being percolated through the rocks that it's just not concentrated enough for most of the organisms to take advantage of.
That could be, Jeff.
Deb, is Kit Bank on the line? Because the Lost City hydrothermal vent actually had very little macrofauna, if I remember correctly. And he could obviously talk to that a lot better than I could. But
Yeah.
interesting about
On the bottom left.
Come in a little bit,
how
video.
little macrofauna is actually found on those vents.
Hold that.
Tim Shank, are you on the line?
Yay!
Hey,
Hey, Tim.
actually, just quite the opposite. Visually, there's almost very few fauna you can see in Lost City. Once you get the samples on board, look under a microscope, there are dozens of species. In fact,
Okay.
shown that there's actually more at Lost City in the carbonate nooks and crannies and the crevices, chimneys,
Jeez.
than there are at the major vent sites on the Mid-Atlantic Ridge. So there's more species in Lost City than there are at Lucky Strike, snake to tag those carbonate.
Look at the Sirius.
Interesting.
Tim, can you look at the Sirius view?
Yeah.
We're in the Alps.
Oh gosh, is this anything like what you saw at Lost City? Just this incredible patina, just a coating of carbonate all over the seafloor for as far as you can see in the ROV.
You know, it's interesting because this is what we saw around the skirts of Lost City.
Oh my!
It's certainly very extensive. But this seems to be cemented.
Yeah, I agree.
Yeah.
Absolutely.
And I haven't seen any active venting yet, right?
Right.
No, but we're going upslope. Oh my goodness.
Fingers or chimneys at the moment. So we haven't seen that structure that I think is so indicative of Lost City, the fingering aspect.
Right.
That's
I
right.
totally agree with you.
So,
Tim, can I ask you another question though about the fauna? How big are the things that you were seeing once you brought the samples up?
Millimeters in size.
Okay,
maybe 2.
All right. So you saw lots of diversity, but they're pretty small.
wow.
Everything was very small, and the key is that not everything was endemic to Lost City. Remember, Lost City is a very shallow area, 800 meters depth, 900 meters. So we had a mixture of sort of shallow, deep sea fauna. There were some endemic to Lost City, meaning that only found there or in association with other vent sites in the Mid-Atlantic Ridge. We had 2 species. So I would say that about half of those that we found in Lost City, of the 65 or so species we found, we felt were endemic.
Okay, we're getting up into a layer of darker material now. This doesn't look to me like anything that I've ever seen in images of the Lost City terrain, but what do you folks think?
It's just now coming up on my screen, so I need a minute to process, and it's kind of pixelated where I am, so doing my best.
Oh, that's too bad. Okay, it looks as if there is essentially a horizontal unconformity of some sort. Something is overlaying this paler layer. Seems to have more or less the same morphology, but not the same color.
So, Patty, at Lost City, there are actively venting fires in areas, and there are inactive areas. Inactive areas look much like the darker things we're seeing here.
Okay.
Similar morphologies. It's like one active vent and one non-active vent side by side.
Wow.
Kind of what we're seeing is that the snow is melted on the tops of these peaks.
Yeah,
and
right.
It just shows you that they're older, I think.
Okay.
Or dissolved, perhaps.
So we're at a depth of 5846. I'm trying to remember when we first how deep we were.
Sediment from me.
What's so interesting to me is these very, very sharp boundaries,
That's
which
weird.
you just mentioned, Patty. Basically,
I don't think
essentially
so.
an unconformity. You can really, so now I'm just catching up. So you can really see
I think
the
that may
difference
be
between the areas that are coated with what looks like a carbonate
venting.
and then the areas that aren't.
Come on up,
And it's
Jim.
amazing just how sharp
Are you
that
seeing
boundary
this
is.
It's incredibly sharp.
D2's view, Patty? This
Yeah.
Sort of,
Fog. Coming into a fog.
I'm sorry, say that again?
So what is causing all the cloudiness in the water right now?
The cloudiness in D2's view right
We
now.
don't
The
think,
cloudiness in the water, that's
we don't think we
not
created
coming from prop wash, right?
I don't think so. We were
Oh,
going up into this, but
Yeah, I think we better follow
I
along.
mean, it's possible that it's coming off of us, but I don't know. Maybe. We keep seeing it.
Okay,
Keep moving up.
yeah.
I think we should keep moving up.
Moving up more or less in the direction of this cloud that's coming out. If there's something going on the seafloor that is producing a lot of effluent, we sure would like to see that.
Okay, we have about an hour left in this dive.
Right, so we're going to need a ship move.
Wow,
Yeah.
an hour.
2 is...
And,
I want to stay
shift
down here
change.
forever.
We don't have enough shift changes to do that.
You
Come
bet,
on
I
in,
know. But this has been totally awesome.
I know.
And we have,
I know.
look, there's a jelly thing. a jelly thing in the water. I don't know. Oh, can we zoom in on that guy?
I lost him.
Okay.
Yeah.
No worries.
Those floaters float off. That's the
Well,
top
look at
of...
how much stuff there is, though. Look at all that. Ugh.
Look at all the debris in the water. Marine snow, we call it.
Or chimney smoke.
Yeah, I think it's chimney smoke.
Chimney smoke.
Can we head forward toward the smoke cloud? Is it possible to go
Do we know
toward the smoke?
what direction it is?
Yeah.
It seems like it's everywhere.
It's everywhere, he says. I think it's toward the scarp.
Oh, upslope.
Yeah, upslope.
Deb, repeat.
I'm still here.
All right, so
So
we're
at
going to need a ship
Lost
move.
City,
It's
aren't
at the
most
end
of
of my
the
tether.
fluids pretty
Yeah.
much clear?
Yes.
Yeah.
Almost
So
all. We had a
What,
beehive or two that
What
looked,
point 2 is 230. They want to follow the
smoky
smoke.
just around when it first came out.
right.
Where I can see it's just kind of up.
So it's actually one of the interesting things about Lost City was that it was
Let's
kind
see,
of hard
say
to
like
see what was
190.
actually venting until you got pretty close
190.
to it, because then you see the shimmering water. So this is interesting that it's
Yeah, understood.
there's
Keep going
so
up.
much more particulate in the water.
Because I'm seeing...
Well, what I'm seeing now
See the
is
terrain.
more layers of light,
Yeah, but you can't-
light
You're going to lose contact
material
soon 'cause I'm going to be pulling you. If you
further up the slope.
Yeah, I know. I'm
It
just
looks
trying to see what's ahead of us.
layered.
yeah.
But we can
You're-
leave the move for the next group.
You want me to come up? Okay, that's a good idea.
Yeah, again, what I remember right is
You're not
the
coming.
darker, I'll say, carbonates were actually
Sean's relieving me, right?
almost like
Oh,
extinct areas.
oh, okay.
Areas where things
Good. Yeah, is Dan close by? Because I need to get
Yeah,
there.
I agree with you, Tim. The very bright white that we saw at Lost City was generally the active stuff.
no doubt. You saw when it was active, it was very fluffy carbonate. It was
Right.
Well,
I haven't
folks-
seen that yet here.
Folks, what we
I'm
did...
still kind of waiting for that definitive look of venting. Right now what I see looks like seepage, and I'm kind of waiting for venting.
Yeah, I agree with you. What we did when we first saw that outcrop, the depth was 58.98, and at the contact with the darker material, it was 58.45. So that's 53 meters of exposure of that lighter coating material. Don't know whether that was, some huge layer of stuff that got precipitated, or whether it was just a coating over that particular portion of the scarp.
And when you first came on, you saw the carnivorous sponge and the crab. Were there other fauna you saw?
There were some, probably 4 or 5 centimeter long and a few millimeter wide, dark.
Stringy hanging things, brown.
Yeah, and there were many of them there, but we didn't really get a good close up of it. And we got swept up the scarp just because the ship and Sirius were in a position, they were moving too fast. We couldn't get back down there.
So, Jeff Drazen, I wonder if you could get on the phone line and give us an overview of what the Hadal Zone really is and why we're exploring there, that kind of thing. What is it that you were expecting? If you have any students there with you and they want to say something, that would be great too.
Yeah, sure. The Hadal Zone are the deepest portions of the ocean. It includes depths below. Usually the typical cutoff is about 6,000 meters, but we don't really know exactly where the Hadal Zone begins precisely. That's part of what we're trying to do here is to look at what sort of animals live along this depths from 5,000 meters on down.
Oh, he's on his way.
But this area extends all the way down to nearly 11,000 meters in the Challenger Deep in the southern portion of the Mariana Trench. And the
So
area
we've been
of
here
these
for about
fatal zones, there's
20
quite a
minutes.
number of, there's a little over 20
We,
trenches in
so
the
it's also
in the
about-
world ocean,
it's gonna
and
take
a
about
number of other
17 minutes to
features
go in
that
once
get
we
below
call in a
6,000
move, so-
meters.
All right.
You're
And
gonna have a couple
altogether,
minutes.
these
It's 10 minutes to
locations
explore here. You only have about
make
43
up only
minutes left in your dive.
about a percent
Okay.
of the surface area of
So
the
you
ocean.
said 17
They
minutes to feel
represent
the effects of the move?
about
Yeah, right
45,
around
the
there.
deepest
Okay.
45%
Yeah, 41
of the
minutes
depth of the
left in
ocean.
the
So
dive.
they're very deep,
Okay, I'm
and
going to push out
they're
towards the wall again until we figure
challenging
out.
to
Go ahead.
explore
It sounds like
because
we
of the
need to
crushing
get a little
pressures
bit away.
and the distance from
Yeah.
the
So
surface
what's
ocean.
Waypoint 2
And
is
they
bearing
had been
238.
explored just a very
But
little
science
bit
was saying maybe go
using
in the direction of the smoke, but we couldn't really
systems
find
from
a
used
direction.
from wires, things like trawls
just kinda on and up.
and cores and
Looks
things
like
like
this is
that
more
from
or
surface
less
ships. And
looking
we're
up
entering a
slope
new
as well.
era now
Yeah,
where
I'd
we're
say
able to use
190.
vehicles like our
180.
ROV here today
Right.
to truly explore
Right.
these
180.
features firsthand rather than
We're out at
just
a
sort of
tether
taking
length
these
right
remote
now,
Yeah.
samples.
and it looks relatively flat up
Today
ahead.
we wanted to
Maybe a
sample
few
in this
turns here,
location,
but-
which is sort of in the
So why
northern
don't we
We
just
did
portion
30 meter
of
or
the
20
Marianas
20
Trench.
meters.
No, just keep
And
moving.
try to
It takes so
sample
long. So
these
just
deep
start
waters
with
below
100
about
meters,
5,000 meters. This is an area
Okay.
that's
and
kind of
what you
been
have to do is stop
missed in
and let the ship
our
backwards.
sampling of
Okay.
the deep ocean. Some of the
Sure.
Mariana Trench has
3.1.
been
Yeah,
a
0.1
popular
for sure.
place to study, particularly the
I'll call
Challenger
it.
Deep because
It's
of
going.
the engineering obstacles and
Bridge,
also
RV.
from some studies wanting to study high pressure
Ready for
adaptations.
another
But
ship
that
to
means that
100
the
meters.
depths up
bearing
on the sides of the
180
trench,
degrees,
including where we are
decimal
now,
1
has sort of
knots.
been neglected. There hasn't been a lot of study in this area. And I am really surprised by what we're seeing here today. I certainly
Good
did not
bridge.
expect a tour through the Alps in the deep trench. But I guess I should say I'm not surprised that we're surprised. There's so little observation at these depths that every time we go, we find something new. And it seems that what's new on this dive are this geologic feature, all of this venting and carbonate precipitation on the rocks, which I'll let the geologists
copy.
talk
Thank you,
about
Bridge.
more.
All
I'm the
right,
fish guy,
expect to move
so
around
no fish thus far.
3:49.
Okay.
Okay, pilots.
So-
I wonder if we
Thanks
could
very much, Jeff.
take a look further up the slope once we can get moving. I think I saw over to the left-hand side more pinnacle-like structures that might actually be old chimneys.
How far to the left?
Go straight ahead now. Huh?
Over, yeah, now it would be straight
Straight ahead.
Straight
Okay.
ahead.
Yeah,
if
we
you
can
can
go
go
for
straight
it.
ahead, that'd be great.
Okay, so we've just called in the ship move.
Jeff, thanks so much.
Go.
Yeah, there's
It'll
a
take 15
little
minutes
story you give
before
about
Sirius starts to move.
why it is that diving to the deepest part of the trench, although that's very exciting, doesn't tell the whole story. What is that story, Jeff?
Yeah. Sure.
We're putting you on the
I can
spot.
tell you that story, Patty. You've heard this story before, of course. When we
I
were
love it.
Together, but
I love it.
They're studying a trench by going to its deepest point, which really is something a lot of people seem to do. It's like studying a mountain by going to the very summit. If you were to go to the top of Mount Everest and take a couple of samples, there would basically you'd be sampling snow and ice. And you would look around and you could not really make much of a conclusion about what the mountain was really about and what sorts of communities lived on that mountain. And the same is true of a trench. You can't just go to the deepest point and say you've been to the trench and that you have some idea of what lives there. And you've got to study the flank. You've got to study all across the depth zones and all across the various different microhabitats that exist in this really large geologic feature.
I like it.
Thank you, Jeff. I love that story.
She's actually told that story a couple of times, and I found it to be really, really cool explanation of why it's important to not only go to the deepest part, but
Right.
to really explore that whole area.
Well, to understand
yeah.
the regional context. Jeff, I've been using the analogy of
A
taking
helicopter.
a
helicopter.
a
Right.
helicopter ride at night to the top of the I was going to say Empire State Building, atop of Everest, and just looking around with a flashlight. But this terrain it stumps me. What are we looking at?
Okay, we have less than an hour for the remainder of our dive, because it takes quite a while for the ROVs to come back up to the surface. We are at 5,838 meters. We're
Okay, I suggest that we need to get moving as soon as the vehicle and ROV are available to do that. I'll leave it to the geologists and to those who have studied these systems like Tim to pick a direction, but I think that our last bit of time would be best served by keeping moving.
But we're waiting for the.
Watch-Lead, you were
yeah,
muted.
actually.
Yes, watch leads. We actually are in the middle of a one large 100 meter
Are you
move.
waiting for
So
a
we are
ship
actually
move right
moving
now?
right
What's
now.
Yes.
It's just
Yes, we're waiting
yeah.
for a ship move. Yes.
Ship move was called in 5 minutes ago, so we'll feel it maybe approximately 10 minutes.
To the top of this.
We're going to be going. We're going to be going up as soon as we're. We have to wait for a ship move. It takes a little bit of time because of the.
We have such a
depth.
tremendous amount of wire out
Yeah.
at this depth.
So that's what we're waiting for.
Yeah, Sirius is
I don't
way
think that's
behind the ROV.
Yeah, I think the question is there still upslope to go to? Like,
Is there still upslope?
Oh, yeah.
Yes.
Oh, there definitely is.
Yes.
Yes. Then
And-
I personally vote for upslope. I personally vote to just keep going up.
Yeah, I agree.
I
Yeah,
agree.
and as soon as we're able to do that, we will. In the meantime, while we're waiting, could we have our ROV crew introduce themselves? These guys are all and girls are from the Global Foundation for Ocean Exploration. Shall we start with those introductions? Because I know there are people following you guys and girls back on shore.
Hi, Watch Lead. This is Jeff. I'm your pilot for the next little bit. And it's pretty exciting to be down here in this trench. I haven't seen anything like this in
Shrimp.
all my ROV dives.
And our navigator
Yes, sitting nav is Sean Kennison.
and our
Yeah,
our co-pilot
Sitting co-pilot is Dan Rogers.
and our videographer over there is
Afternoon, I'm Tara Smithy.
Yep. And
our clipper.
Afternoon.
You're out at the end of your tether there.
Annie is our clipper. What that means is Annie is sitting here looking at the video as we go along the seafloor, and she is grabbing beautiful
editing, yeah.
video to provide any of you folks at home a view of the entire dive, but sort of clips of the bests of.
You'll be seeing some of those highlight videos on the Ocean Explorer website probably in a couple days, I think. Maybe tonight or tomorrow.
Tonight, yeah. So if anybody wants to take another look at what we saw, this incredible dive, anybody, you could just go to the oceanexplorer.noaa.gov site and look for video, and sure enough, you can just redo all this excitement.
The other thing, too, is that there's a replay of the dive, basically just, I think, maybe a couple of hours after we finish this dive. They start replaying it. So if you go to the oceanexplorer.noaa.gov website, you can actually see a replay of this entire dive. It'll be about 3.5 hours long. So for those of you who are in the East Coast, or like Tina from Russia, you can actually, you won't see it in real time, but you'll be able to see the entire dive.
So I have one little thing to add. Both Diva and I have been tweeting some of these images, so if you can't wait until tomorrow, you can see a lot of these really cool images on Twitter.
Great.
Well, thank you, guys. That's wonderful.
I think there's also a Facebook fan page or something called, is it called Underwater Images? I don't remember.
Screen grabs. It was
Underwater
screen grabs?
I don't
Something like that.
remember. You can tell I don't do Facebook.
It's
called underwater webcam screenshot.
Okay, underwater
thank you.
webcam screenshot. So you Facebookers can go and
Yeah, I
take a
think
look
I'm
at
starting to
those
move here.
images as well. People have been
Finally.
doing screen grabs all over the place because there's so
Yep,
much
we're definitely
interesting,
moving.
topography, the biology, the geology to see.
If our videographer pilot, would it be possible for the videographer to zoom in a little bit on these rocks, or on the, I should say, outcrop, because we don't know what they are?
Sure.
And the reason I'm asking is because it looked to me the last time we did that there were clumps of rock that were encased in some of this material.
Okay, Tara, let's go partial here.
Sure. It's a partial.
This looks pretty similar to mud flows of serpentine that come out of some of the serpentinite mud volcanoes that we'll be studying in a couple of dives further on. Also, it looks like there may be some biological things, just very thin sort of fibers hanging down from the surface of some of these.
That might be some of that blacks.
Yeah, the little black fibers that we saw early down.
Yep.
Thank you, pilot. That's great.
Okay, full wide, please.
Yeah, folks at home who are anxious to get moving up the slope, we aren't quite in position with
a ship,
Sirius yet. The Sirius camera pointing toward the ROV is at about a 45-degree angle. When we're really ready to make tracks with the ROV, that arrow that indicates the relative positions points vertically down, and that means that Sirius is right on top of the ROV, and that gives the ROV slack of about 30 meters worth of tether to move around.
Tara, we can take another look at this. This looks a little different.
Sure thing.
So our target depth at our end point is 5,750 meters deep. We're at 5836. So as soon as we get in position with the ship, we'll be able to go ahead and move quickly. I'd say move quickly upslope so that we can get to the top.
Looks like the slope might actually be a little off to our starboard side.
Okay.
And I can see you're turning into it as well.
Yeah, pilots, but do you want the ship adjusted? Right now we're going due south.
Well, if we...
I think,
how big is that turn there?
Let's get
pilot,
started.
I think we should be,
Once we get on the
pilot and nav, I think we should be going kind of southwest upslope.
Copy that.
So we're only going 0.1. I was thinking there might be a bit of like a swing around as we change direction, but we're going pretty slow right now. So yeah, why don't we go ahead and if you lateral starboard, Jeff, a bit.
Yep.
And I'll find the slope.
Yes, we've made about 30 meters south. So we can adjust direction.
Yeah.
Once you turn and find a good spot with sonar.
Yeah, why don't you come up and lateral starboard a bit?
Sure.
The texture of what we're seeing in the video right now reminds me a lot of serpentinite mud flow material.
Like a 190 roughly. Does that match with what HiPAC? I mean, not that you have a great return on Sirius, but
yeah. So HiPAC's seeing about almost 230
from the ship, right? Or oh, I see. You're just going upslope.
Oh, just for slope, yeah. Oh, towards waypoint 2.
It's a little tough.
Yeah, yeah. So waypoint 2 is about 215 from Sirius. So I think maybe even like a
200.
Yeah, 200.
How does that look to you, Jeff?
What we're looking at, these two ridges, one ridge on the right side, one ridge in the center, and some channels between. This looks like channels that have come that are formed by erosion
What
of
did Hypack say?
a serpentine
230?
mud flow. What's fascinating to
The
me
slope is about 230.
is that
but to get
these
Sirius to
we're
waypoint
seeing a
2,
series of
it's about
pinnacles of
215.
these things, which looks
Why
like
don't we compromise and say
dismemberment
215?
of the
It does.
flank
Yeah.
of
It does. It's like
Let's do
that
it.
crack
Let's
in
change that
between
direction
the
to
two.
Yeah.
215.
And these
got
things
it.
do have enormous big chunks of slump, like you have a sector collapse on the flanks of some of these mud volcanoes.
Like
Do
when
somebody
icebergs.
keep it at 100
calve.
meters?
Yeah, when icebergs calve off a glacier. Yeah.
That way they don't stop.
Yeah.
The last thing we want to do is stop right now.
And it looks from the Sirius view as if upslope
Wow.
is
That's
to the
awesome.
left of the Sirius view.
Unbelievable.
I just,
Unbelievable.
you know, even if we don't make it to the top
Oh,
of
we're
this
gonna make
thing,
it to the top.
well, even if we don't, this has been an eye-opener of a dive.
Patty, this is Deb. I have to tell you, this is totally not what I expected of this dive. I don't know what I expected, but this certainly was not it.
Oh, no, me too, Deb. This is not what I expected either. I thought pretty much
So
we'd
thanks,
just...
guys. You picked a fantastic location.
This is really exciting. The sonar image shows a whole bunch of these pinnacles and little rivulets between them. Incredible contorted topography. It's so fascinating to me that, you know, we'll see bathymetry that is smoothed based on a computer's idea of what the seafloor looks like, and then you get down there and look at this, folks. I mean, this is
Just kind of
so
make your way
delicate
starboard as
by
you come up.
comparison to
We're
what we
looking
see
good, though.
on the bathymetry record.
I'm facing 215 now.
The Earth holds her secrets dear, close to the chest.
Hey, Sean, I'm just curious, what's the slope on that steepest part?
What I'm seeing in the Sirius view looks like a series of little scarps that indicate a series of blocks of slumped material down the flank of the trench slope.
Look at that.
On land, when you're looking at...
So that's almost at the steepest point, about a 45-degree angle.
Okay.
When you're looking at Bryce Canyon or something, you see erosional features that look a lot like this. They're called hoodoos. I think that's just a cool word that land morphologists use to describe the erosional remnants of layered sediments in an ancient lake. But this has the same morphology. I think these are ancient mud flows of serpentinized peridotite. And that's hydrated mantle rock and carbonates, and here we go, back into the really pale looking stuff on the top. I'm transfixed. This is wonderful stuff. Incredibly steep slopes on some of these scarps that are off to the right-hand side. Those have got to be close to 70 degrees. And at the top, close to 45-degree slopes. Obviously, this stuff is sticky enough to hold together.
Tara, can we just zoom in on the broken rock here?
Of course.
Okay.
So what we're seeing here is, it truly is rubble. So they're little fragments of rock that are encased in probably a sticky matrix of ground up material of the same sort. The serpentine mudflows have the consistency of cream cheese.
Yeah, so I was just going to ask you about that. How different is this from what we expect to see at the mud volcanoes?
It's very similar.
Yeah.
So we see a whole bunch of clasts of rocks that are brought up. If this is indeed mudflow material that we're looking at, this close to the trench, this will be stuff that is brought up through the overriding tectonic plate below the sea surface. So right at the contact between the downgoing Pacific plate and what's on top of it. Wow, this is amazing. The view in Sirius is just
I know,
stunning.
it's spectacular.
We're basically
I just took a video of it with my iPhone. That's how cool it is. It's like, wow.
And our videographers are capturing these things, so you folks at home can take a look at your leisure once again at this tremendous high-def video that we're getting from the remotely operated vehicle's camera.
It's Deep Discoverer.
Deep Discoverer. D2, Deep Discoverer. The Okeanos Explorer's remotely operated vehicle, which is now at a depth of 8,518 meters. Now look at this streak of white through this outcrop on the left side of the screen. Usually
So that's carbonate, right? That's the carbonate
Usually
then?
the really white stuff is carbonate rich.
Here we are on another mound. Top of a pinnacle, maybe?
Yeah, we're going up a ridge. And we'll see how far we get. We're hoping that if we can get far enough up here, we may see some really large carbonate chimney structures. So what we're looking at right now looks like mud flow material. It's not pure carbonate that is autogenically, that means in place on the seafloor, precipitating.
Yeah. So look at those streaks then through that.
Yep. There's streaks to the left of us, streaks to the right of us.
Just so everyone's aware, we have approximately 20 minutes left before we need to start setting up to get off bottom.
Okay, thank you, pilots. Thank you, Nav. So 20 minutes more.
Watch lead nav. Watch lead pilot.
Yeah, go ahead.
So are we in a position now with the ship where we can actually start moving up?
We've been moving.
We are
for
moving
about
up
20 minutes.
Faster, though. I guess faster.
Well, we don't know exactly what the terrain is in front of us, and so we're taking an abundance of caution here.
Yeah, got it.
But we are moving forward and have been.
Okay.
Okay, and we'll continue to move. We're not stopping anymore. It's just moving on.
Roger that.
I mean, unless you see something we need to stop.
No, we want to see the top.
That's 5,800 meters from here. And you'll see that about 8:30 tonight.
Nobody likes a wise guy.
This is Watch Lead 1, and I understand you, pilot. I have a very excited biologist next to me.
Like, faster, faster.
I want to know why the geologist never joins us during the water column transects. Is there nothing there?
Well, if a volcano is erupting and rocks are falling through the column of the water, I'll be here.
Okay. Well, look, I think I found you a rock. Look right here. There's sort of a dark colored rock.
You can see
There is a dark colored rock.
There is a dark colored rock. Nice, keep going.
Oh, yeah.
Pushing it down slope.
Yeah,
a
we
bit.
should probably mosey on up these ridges.
Can you zoom in on Sirius too? Do you have a chance?
Rock.
Tara?
That rock that's there is
Can you zoom in
likely
on Sirius?
ultramafic. In other words, a piece of peridotite, which is what the mantle's made out of. And
Yeah,
it looks
there.
like it's coated with some manganese. I'm not sure if we're in a position to collect
We're
it
not.
or not.
We're not. we can't. Really? I don't think we are, right? We're not in a position to collect, are we? Not unless we want to get to the top. We want to get to the top. We have less than 20 minutes. We're at 5,810 meters. The target depth for the endpoint was 5,750. So we have about 60 meters to go upslope. Could be more than that.
Yeah, pilot, we can go on up.
Okay. The first thing I notice here is that all of this sediment is extremely fine.
Yeah.
And extremely loose.
Yep.
In the Sirius view, you can see the prop wash underneath, and I probably just nudged it with my toe here, and that's the kind of clouds we're getting. But if you are interested in a rock, we will try to find one.
Let's see what we see as we go up the slope here.
I think Watchley, you're muted if you're
Yeah,
talking
go
to
ahead.
me.
Go ahead, Patty. Go ahead.
Oh, I'm sorry. Yeah, sorry, I was muted, pilot. That was stupid. I think if we go up, we are likely to get ourselves in a position where it might be easier to pick up a sample. So,
Okay, thanks. That was a nice shot.
and maybe we can aim for trying to pick one up right before we leave the bottom, because I bet all of these are relatively similar. So what we saw on the bathymetry is where we were planning the dive was that the wall of this this part of the trench had a series of little canyons and ridges. The folks in Hawaii would recognize that topography as the sort of thing that you see on the what we call the poly, or the cliff on the windward side of Oahu.
So we just passed through 5,800 meters.
Great.
We've come up 200 meters since the start of the dive.
And this material all looks like serpentinite mud flow to me. The fact that it has cobbles, pebbles of other lithologies in it suggests that it is a mud flow. And what we're coming to now, we have layering that may indicate a flow that had fewer rocks in it,
So after we leave the bottom, which is going to be in a few minutes. It'll take a few hours for D2 and Sirius to get back up to the surface. So we'll all be excited to see what that rock looked like that we collected. Yeah, less than 20 minutes. Yeah.
Watch lead. Any of these rocks look interesting? That is interesting as a sample.
Yeah, I think so. I think we'll probably see similar rocks up towards the top. So, and we're close to the target depth anyway. So, yeah.
I'm just thinking we've got, what, 15 minutes? Is that right, Sean?
Yeah, max 15 minutes.
Max
15
15 minutes. This might be a good opportunity.
Okay, why don't we go ahead and do that then?
All right.
Thank you.
Do we want to bring the ship to a stop?
We should have enough time.
Yeah, I think we can
I'm
keep
way
it
out in
going.
front.
Okay. Well, I mean, because right after this, we're probably going to have to start pulling up, right?
Yeah.
And the ship is going to have to move kind of almost opposite of the direction we're moving right now. If it's going to come ahead.
Okay, so just to clarify, are we going to have to reposition again? Because if we are, and that would jeopardize us getting to the top, my preference would be to not collect.
I think it's just a matter of time.
Yeah.
Yeah, we don't have to reposition the ship at all.
Okay.
Yeah, we're just waiting for movement from Sirius. But
Okay, thanks.
But any time that I spend collecting the rock won't be spent getting to the top.
Yeah.
You know what I mean?
Yeah.
So, your call.
I'm inclined to move. I'm inclined to move to the top,
Okay.
and then let's move to the top and see, and then if we've got time when we get up there, then we'll collect, because it's more important, I think, for us to get to the target waypoint for the end of the dive.
Are we going to make it to waypoint 2, Sean?
So, folks on shore, is there any opinion about
we might
that?
be able to get a glimpse from the distance, but that's about it.
Okay.
Tara's saying go to the top if we can.
Okay. Should we?
I defer to Jeff on that question.
Dan, do you want to pick up the pace?
Yeah, I could go to point 2.
Let's go to point 2.
Well, I mean, I think we should just keep trying to cover as much ground as we can in the hopes that maybe we find some more concentrated venting or something of that nature. I think this is, we probably only have, 30 minutes left or something like that?
Not even. About 15.
I would stay moving. Keep moving.
Okay.
Patty, the only thing I would say that would tenor that is that if you think there's one last sample you want to take somewhere that would be useful, but otherwise I'd keep moving.
Yeah, I think the consensus is keep moving. Sorry.
Okay. I was just going to say it's not Patty, it's Casey. Patty stepped out for a minute.
Patty stepped out. She was having a coughing fit.
So, Jeff, you want to maybe talk a little bit about what this is that we're seeing for folks
Right
that
now,
are just joining us? This is, as a biologist, this seems pretty different than what I was expecting down here.
Way different. So now it looks like there's some.
Patty, you want to go ahead and describe what we're seeing here and what creates these features?
Okay, so Patty's not in the room right now, and we were hoping maybe Jeff could do that.
We don't necessarily need the description of the features, but you've worked at these depths before. Is this normal? Is this what you see a lot of?
Look at that. Yeah, what's causing that brown now? We're seeing kind of like a brown coating to the top of this ridge. Wow, look at that.
Yeah,
look
not
at
much
that.
feather left.
Okay.
Wow.
Yeah, this looks like something you'd see in the Badlands of California,
Yeah.
Nevada, or something like that, with these layered structures. It really is unlike anything I've ever seen underwater.
Could these be microbial? Would they make that kind of coloration on the rocks?
Is it sulfur?
Jeff, do you have a guess?
So this is
Yeah, go ahead.
this Tara, I would say that microorganisms can do just about anything. Whether they actually did this or not, I don't know. But sure, it's certainly possible.
Wow, this is beautiful. This is really amazing. That shot, the other shots from the
other
D2,
cameras.
the other camera that's positioned down by the collection skid. It's just an amazing imagery up there. Let's make a nice poster.
Video, this is watch lead. Would it be possible to get some of the HD manipulator cams up on the quad view for at least a minute or two so people can see? Let's take high pack and the sonar just for now. And like I said, just a minute or two so people can see, and we can go back. Thank you, Tara.
What is that?
Zoom biology. She's got her hands full right now.
Sorry, was somebody talking to me? No.
Tara, can we zoom main HD on?
So those of you on shore should now be able to look at video feed 3 and see some of the additional views of one of the other cameras that we have.
Oh, is that a polychaete?
What is?
Is that a polychaete?
Sure does look like it. Oh, I don't know. Yes. Yes.
Polychaete worm. Tim Shank.
Oh, wow.
Tim Shank and I saw things like this swimming around when we were out with the Nereus in the Challenger Deep. And sometimes these little critters have bioluminescence in iridescent colors in their little legs as they move them around.
Okay, I can't hold that.
And I am fascinated by these stripy rocks, and I have no idea what this is.
Bruce Mundy said it almost looks like a topographic map with isobaths.
Exactly. You know, I just zipped back into the room here, and that's what I was thinking too. Hey, how come they put depth marks on these mountains for us? This has been the most fascinating dive I have
really
ever
amazing.
taken
I know, really,
in my,
really amazing.
at least my life up to now.
Yeah, this is amazing.
Maybe tomorrow
Yeah.
will be even better.
Or we'll go to your mud volcanoes.
Yeehaw! Oh man, I sure hope they live up to this. It's a stunning,
Really amazing.
stunning,
Really
stunning
amazing.
video. Stunning seafloor.
So we're having a little online chat between two of our shore-based scientists, Scott France and Andrea Quattrini. Scott wanted to know if isn't this reminiscent of some of the canyon walls in the Atlantic, the carbonate and the layering, not necessarily the dramatic mountain shapes, but the layering.
Oh, definitely.
Yeah.
Yeah, Scott, that's true.
We were at 5,777 meters. And the Hadel Ridge, the Mariana Trench. Now we've got that brown all on the top, darker brown.
Yeah, I
What do
know.
you suppose
I
that is?
know what that brown is.
You do? What is it?
Gee, it's nice to know what something is out there. That brown stuff is pelagic sediment. Oh, at last, something I can identify. This is in the Marianas. Actually, there's